In this lecture, I am going to share some very important points about centripetal force. What is centripetal force? It is a force which is necessary for a circular motion to take place, and it is needed due to inertia of direction. Suppose a body is moving along a straight line. I want to make it move along a circular path, means I want to change its direction. But by itself, the body is not able to change its direction because of inertia of direction. So I will have to apply some force in order to change the direction. This required force is called centripetal force. So we can define centripetal force as the force that is necessary force for circular motion to take place. And this force always acts along the radius of the circular path and towards center of the circular path. In order to have more understanding, let me take an example. Suppose a cyclist is moving along a road, and this is center of mass of the cyclist and the cycle. It will have a weight in vertically downward direction, and a normal reaction will act on the system due to plain road when it is moving in a straight line. Suppose it wants to take a turn, means it wants to follow a circular path. So turn is a part of circular path. As it is, the cyclist will not be able to take a turn. It will have to bend a little towards center of the circular path. So that is called bending of cyclist. Question is why the cyclist bends while taking a turn. By bending through some angle, a source of centripetal force comes into play. The vertical component will be r cos theta and horizontal component will be r sin theta. So normal reaction gets resolved into two rectangular components. This vertical component r cos theta will balance weight of the body, and r sin theta component is left, and this component provides the required centripetal force. This is how bending of cyclist helps to take a turn. Because due to this centripetal force, the cyclist can easily take a turn. Let me take another example of banking of roads. At a turn, why it is a road is banked? Banking means outer edge of a road. Suppose this is a road, at the point of turning, its outer edge is raised a little bit in comparison to the inner edge. So this is also an example of providing centripetal force. Now let us try to understand how this banking provides centripetal force. When this outer edge and inner edge of the road at the turn are at the normal level, are at the same level, then suppose this is a vehicle that is moving on the road. This vehicle will have weight in vertically downward direction, and a normal reaction will act on the vehicle, and r vector equal and opposite to weight of the body, they balance each other, and no force is left for the vehicle to provide centripetal force and at the time of turning on the road. Now we shall understand when outer edge is a little raised above, Then how it helps for providing centripetal force. If the outer edge of the road is little raised above through some angle, then the vehicle will also be tilted through that angle. Let us suppose this angle is theta. When vehicle is tilted, then the normal reaction acting on the vehicle due to road will also be making angle theta with a vertically upward direction. And weight of the vehicle will act in the vertically downward direction. As done earlier, this normal reaction can be resolved into two components. One component in vertical direction, and that will be r cos theta, and horizontal component will be r sin theta. Out of these two components, r cos theta balances weight of the body and r sin theta is left for providing necessary centripetal force at the time of taking a turn. So this is the importance of centripetal force and importance of banking of roads for vehicles to get centripetal force while taking a turn.